Hello, in this video, we will look at a case study on minimum number of changes. Suppose you wanted to develop a program that classifies a given amount of money into smaller monetary units. The program let the user enter an amount as a floating point value, representing a total in dollars and cents, and then output a report listing the monetary equivalent in dollars, quarters, dimes, nickels, and pennies. So look at this program here. So we have this is 11.56. So that means $11.56. So the program take this input and we'll generate this output as $11, 2 quarters, 0 dimes, 1 nickels, and 1 pennies. So we're going to write a program to get the dollar, the maximum number of dollars, and then the maximum number of quarters, and then the maximum number of dimes, nickels, and pennies. How do you write this program? So we are going to write this program here is to prompt the user for the input. This is the amount. And now we're going to go to convert this 11.56 into the integer 11,056. So we're going to have this amount times 100 and then cast it into integer. So this is to use this function to obtain this from this float to int. So you can use this function int. Now we have this remaining amount, this all the cents. So we can get the number of dollars here using this. Remaining amount, remainder, divided by 100, and then get the integer of it. So that is the number of dollars. Now you can actually get the number of dollars by just simply writing this code here is this remaining amount divided by integer division divided by 100. So that gives you the number of $1. And now remove the dollars from the remaining amount. So this remaining amount remainder 100. So those are the cents on the $1. So this, in the remaining amount, we get the maximum number of quarters. So this remaining amount, and doing this using integer division, get this 25. So this is the number of quarters. And after this, so we now remove the number of quarters. So we have this remaining amount, remainder 25. So in the remaining amount, we get the maximum number of dimes. So this integer division and 10. So we're going to get this number of dimes. Now remove the number of dimes. We have the remaining amount, remainder 10. So this is right here. So now for the nickels here, remaining amount, integer division 5. And now here, after removing the nickels, remaining amount, remainder 5. So what is left? They're all the pennies. This is the output. And this is the example. For example, I'm having this 45, 45, $45.45. So what is the output? Is, I'm going to rerun the program now, is 45.45 run. So let's go back here, 45.45, now run. So this is what you have now, $45.45 as $45, 1/4, 2 dimes, and that's all. Now, let's use a different output, different input. Sorry, this is 10.03. So let's try this, $10.03. I'm going to run this program now. So you see what is the output you have? It is $10, that's right, but only 2 pennies. So the problem we have here is right here. You see the problem is, it's going to be right here, must be here, is when you perform this from the floating point number and you use the int function to get the integer, and this is, there is a loss of accuracy here. Floating point number itself is the represented in approximation. So I'm going to write this, and you're going to see what happens is I'm going to run this program now with this print. I'm going to print this now, print remaining amount. So I know that is the problem. So if you print the remaining amount, so now, and see what happens, the remaining amount is 1,002. So what happens is, I think if you, let's try it, see if we can get that picture here, is this is amount times 100. Let's see what is the amount times 100 displayed. So that is something very clear, is 1,002.9999, all here nines. So that is approximated 1,003. But when you performing this int here, it's like doing a casting here. The fractional part is truncated, and so only left is the integer part, that's 1,002. Now we can fix this problem in the program exercise. We can fix this. So what we do is here, you can rewrite the code. Here, rewrite the code. Instead of letting the user enter a floating point number, you ask the user to enter the whole number, the integer, 11,056. So you will get the accurate result. That is all for this case study. Thank you for watching. See you on the next video.